Hey, good afternoon, everybody. We are on episode 2 of the Hitchhiker's Guide to Hacking Connected Cars. And in our first episode, we discussed how to get your BladeRF set up. And um, we installed the BladeRF CLI and the BladeRF FPGA package for the X40 and also upgrade it to the latest firmware. So that is here. So you now should have your fully updated BladeRF running and connected to the USB cable of your laptop. So I'm going to take just a minute out here to explain. I'm going to take a step back and explain what it is we're doing, why, and penetration testing of head units and telematics control units in general. Um, there will be a corresponding diagram with this video as well as a blog article, and this will actually be part of the book that I'm currently writing, which will be published in early 2018 by Wiley. So with that being said, let's first talk about penetration testing of head units. One of the first things that you may be wondering is, what does a BladeRF have to do with penetration testing an infotainment system slash head unit or a telematics control unit? So there's different attack vectors um, that affect telematics control units. You have to understand the architecture of a connected car. A head unit is basically the nerve center of the automobile, as now really becoming an additional control panel for controlling the lights and other functionality within the automobile. Originally, the head unit really was just for, GPS and nav, setting, your music, pairing your phone, and, listening to music over Bluetooth or what have you. Now, automobile manufacturers have really taken that further and really making it a secondary or tertiary instrumentation panel for the controlling the functionality of the vehicle. The reason why we are setting up a BladeRF is so we can create what's called a rogue base station. A rogue base station is effectively setting up a cell tower with a software-defined radio and fooling the telematics control unit or the TCO, which will typically communicate with the backend of the OEM over GSM, over cell. And so with our base station, we can project a stronger signal being closer to the automobile than the legitimate base station and have the telematics control unit associate with our rogue base station, effectively controlling the network medium that the TCU is connected to. This will allow us to intercept SMS text messages going that it's attempting to send to the backend and hopefully grab some other useful information. In order to do that, you need an RTL SDR. Now, you can go online and you can say, well, Alyssa, I can, why pay $400 or even over $1,000 for a BladeRF little RTL SDR stick for about $9? The reason why is that those little cheap RTL SDR sticks are great if you want to, for example, stream FM radio, but they don't have the ability to go into the much higher frequencies that a BladeRF can. And also, you can only receive, you can't transmit. Whereas a BladeRF is both RX and transmit. You can see that here on the casing. You have an antenna for receive and antenna for transmit. So it is a full duplex RTL SDR. In the last episode, I referenced the BladeRF X125. I was actually wrong. It's an X115. So there's two models that Nuance makes. There's the X40 and the X115. The major difference between the X40 and the X115 really is, like I had said in the last episode, it really comes down to the X115 can operate in more extreme temperatures. So, for the purposes of what we're doing, there's really no reason to spend over $1,000 on the X115. Sorry, Nuand, I want to give you guys that business, but if you're doing penetration testing in a lab environment for testing a TCU over GSM, there's really the X40 is fine. Okay, so we talked a little bit about, kind of like why we're doing this. The other thing that I want to bring up is in you'll hear me refer to the concept of a jump kit. This is a Wi-Fi pineapple, and there is actually also, this is made by a company called Hack5. They have an awesome YouTube channel and some awesome shows on YouTube. Check them out. But the Wi-Fi pineapple will let you actually create a rogue access point. The purpose of creating a rogue access point is your head units will often have Wi-Fi capabilities. Now, in some of the penetration tests that I've performed, the head unit will communicate with the TCU over Wi-Fi. So there's a private network that is not beaconed, excuse me. There's a private ESSID that is typically not beaconed out that the TCU will communicate to with the wireless, with the head unit. So the TCU needs to communicate with the head unit, and that's typically over wireless. That's typically over a hidden wireless network that the infotainment system or a head unit would not broadcast for obvious reasons. Now, the head unit will typically have a wireless access point that it will broadcast within the car for the driver to connect their phone to for internet access. As a matter of fact, the Opel that we rented here in Stuttgart, Germany, does have a wireless access point in it. So there's, depending on the manufacturer, depending on the implementation, the head unit will typically communicate with the TCU over wireless. A lot of the previous implementations used to be tethered, for example, for USB, but a lot of the manufacturers that we've been working with as of late have started to move to wireless. Okay, so that's the point of the pineapple, is that if you can get the ESSID information and the BSSID and all that fun jazz, and figure out how the TCU is connecting to the head unit, you can fire up a Wi-Fi pineapple and set up an evil twin. So what's an evil twin? An evil twin is where you fool the unsuspecting client device or mobile equipment to communicate with you or associate with you, thinking that you are the legitimate wireless access point. So we are here in Germany doing a penetration test right now of a head unit, and that's exactly what we were able to do. So basically, in our penetration test, we were able to fire up an evil twin and broadcast with a stronger signal the SSID of the legitimate head unit, and sent a deassociation broadcast and disassociated the TCU from the head unit and got it to actually connect to us. It was really cool. So you're going to need to invest in a pineapple. Unfortunately, and I did say this in my article, being a penetration tester of TCUs and head units and really IoT in general, your jump kit or your kit that you use for penetration testing is not going to be cheap. A penetration tester who's targeting, a computer network they're going to be using, they're going to be spending their money on a laptop. They're going to be using, Kali or Parrot or, some sort of Linux distro. And they're probably not going to be having to invest in one of these, or, they may invest in a Pineapple, but, there's no reason for them to fire up a rogue GSM base station. But we're in a very specialized area of red team of penetration testing where we're targeting IoT devices, which in many instances use GSM or wireless or Bluetooth. And we'll talk about Bluetooth later, but your kit is not going to be cheap. So this is $499 US dollars. I think here in Germany, the resellers are selling it for even more than that. So it's north of 500 euro here. You've got the Wi-Fi Pineapple Tetra, and you have the Wi-Fi Pineapple Nano. Now, Hack5 makes two models. The Nano, which I've actually got here somewhere. Yes, the Nano, you can imagine how stealthy you can be with something with this compared to this. Is they have a tactical version that you can buy a little pack for, and it's very easy to walk around with it and hide it. Just in general, this thing is small and shy. Anyway, the difference between these two pineapples is very simple. This can do 5 gigahertz. This can only do 2.4. So we actually ran into a problem on this pen test because originally we were using a Nano and the head unit was acting as the wireless access point. It was acting as the base station, and the TCU was connecting to it. And it was using the 5 gigahertz channel and doing communication over 5 gigahertz. This wasn't working. And it took about a day for us to actually figure that out. We posted help on the forum in Hack5, and somebody very kindly reminded us that it's only 2.4. So, oops. Yeah, it's gonna happen in your pen tests. But yeah, read the fine print. That's why you're gonna want something like this to do your penetration testing. Okay, so I want to explain the architecture again, just real fast. So we are doing a penetration test of a head unit. And when you're doing a penetration test of a head unit, even though it's technically not in scope, it is kind of in scope, the TCU that is communicating with. Because a lot of times you'll want to be, doing an evil twin and fooling the TCU into connecting it with you, thinking that you're the head unit. It's really hard to leave a TCU completely out of scope. Now you're going to find vulnerabilities. When you're writing your report, just be very cognizant of that. That what vulnerabilities are for the TCU, which ones are for the head unit, because in a lot of OEMs it's completely separate teams, completely separate departments or business units, and you just want to be very careful of not of no scope creep. Okay, so TCU head units, rogue base station primarily to attack the TCU. I have never seen the head unit actually communicating with the outside world, with the head unit actually having a SIM chip in it and communicating over GSM. I've just never seen it. And we work with all sorts of different manufacturers. There's always a TCU. Don't mix that up with ECUs, which is electronic control units. But typically the head unit is always connected with the TCU, and that's the gateway to the outside world in the back end. So, all right, you understand the architecture better now. The head unit typically acts as the base station, so remember that. So the base station is not typically the TCU. The base station or the wireless access point is typically the head unit, all right? So, okay, so we are building our kit, our jump kit, and the first thing we want to do is we want to get this guy working. We want to be able to fire up a rogue base station. Now, it's not as simple as just getting this BladeRF configured and you've got a rogue base station. It doesn't work that way. You need to download GNU Radio. You need to download YateBTS, all of those things in order to get this thing fully working. So we are going to do that together tonight. So again, in the first episode, we got the BladeRF upgraded to the latest firmware. And I'm just going to walk you through, actually now how to do the rest of it. All right. So as I said in the last episode, I'm using TeamViewer. So let's go ahead and fire up a shell. Okay. Now, some of you are going to hate me for this, but I was too lazy to reinstall Linux and do all this from scratch again. So you're going to see some stuff where I'm doing the apt-gets where it's just going to be really fast because the package is already installed. But I'm still going to give you guys the commands because that's really what you care about. I'm going to still explain stuff along the way because that's what you care about. So the first step is we want to install GNU Radio and GQRX. All right, so to do that, we're just going to go in here, obviously make sure you're root, and we're going to do an apt-get install Apache. Oops, I lied. We're going to do an apt-get install GNU Radio, libboost all dev, gr osmo sdr, and gqrx sdr. Okay, so that's going to go through and download a whole bunch of crap. It's going to take a while, not too long, and it's going to get everything installed. After you get GNU Radio installed, and again, I want to underscore the importance of this again. Make sure not to install both the package and GNU Radio from source. Bad idea. It's going to be a total mess. You're probably wondering what I'm drinking. It's Leaf Cup, Darjeeling Summer Gold, Rose Hips tea or something. The tea in Germany is amazing. I don't know, the tea and the milk. I don't know what's with the cows in Germany. I don't know if they're happier, but the milk in Germany is just super yummy. Way different from the US. Okay. All right. apt-get install Apache 2. So this will install Apache 2. And obviously, one of the things that you're going to need Apache 2 for is there's a web-based interface to YateBTS Yate called Network in a Box or NIB. And I'll be showing you guys that here in a minute as well. The next command you're going to do is you're going to add the apt repository for installing the latest version of PHP. This actually took me like several hours to figure out. A lot of the articles and a lot of the things refer to the older versions of PHP. This new version of Linux Mint Sonia, I think is what I'm using. You need to add the apt repository for the latest version of PHP, and we're going to install 5.6. So I am saving you guys a lot of hours. Took me a better part of a day to get all these instructions written up. Do not think I've memorized all this. I'm good, I'm not that good. I'm much older than I look, and yeah, I'm not a spring onion anymore. Spring chicken, spring onion. Okay, so this will add the repository for PHP. That took a while, didn't it? This will add the key, and then we're just going to do, whenever you add a new PPA to your repository, you always want to do an apt-get update. And that will, of course, take on all of the new sources and allow you to begin installing packages from your new locations. Okay, and then it's as simple as apt-get install PHP 5.6. And some of you guys are probably skipping through and fast forwarding through this stuff. I'm putting all of these into the description of the video below. So if you guys want to just copy and paste from there, but at least you guys will be able to see this thing up and running if you're fast forwarding. So next we're going to install Yate. Let me make that very clear. Yate and YateBTS are actually two completely separate packages. And actually, yesterday I couldn't remember what Yate stood for. It's like yet another telephony equipment, I think, something like that. Anyway, two totally separate packages. So one thing that you're going to need to do is install Subversion, make autoconf gcc libusb 1.0/0/dev-dev. libgsm 1-dev, and you should be good to go. Now, one of the things that you need to be really careful of, and I actually really messed this up before, um, is do not forget to install libusb, because it will fail when you compile Yate. And I actually, the folks on the Yate IRC channel on Freenode were awesome, and I got some help, which was surprising because in the United States, um, they would have been asleep. I think they're in a different country. It's actually .ru domains. I think they're in Russia. Anyway, got some awesome help, and it turns out that all my woes and problems with Yate were simply because I was missing libusb, and it uses that to compile the module that it needs. I think it's called YBladeRF. Anyway, so make sure you get all that stuff installed. And then once you do that, you're going to add group Yate, and we're going to stick our user in there. We're going to do user mod -a -g Yate, and then listenite, and that just adds your current user to the group. And then apt-get install autoconf doxygen build essential, and that will just make sure that you've got all the compilers and everything you need. Doxygen, that's really, for it to generate all of the documentation. Probably won't need it, but I'd do it anyway. Then you're going to go to /user source, and you're going to do an svn checkout, http voip.null.ru. I think I have .ro. Oh, it's .ro. svn Yate trunk. Maybe they're not in Russia. Maybe it's dot. I was thinking it was .ru, and maybe it's not. Anyway, I think I forgot to. Yeah, I meant to put. Oops. Hold on. Yeah, I forgot to put Yate. Yeah, you guys don't mess that up. Don't do what I just did. Let's delete trunk. Don't forget to put Yate at the end. That way you actually svn checkout into Yate. I mean, I guess you could just rename it. Oh well, whatever. MB it to a new directory called Yate, whatever. So after that, you're just gonna hop into the Yate directory, and we're there. We're in user local user source Yate, and we're just gonna type autogen.sh configure prefix equals to user local semicolon make install. Okay, so you're probably wondering what the so for those of you who didn't know this, but you can actually combine multiple Linux commands on the same command line and separate them by semicolons or ampersand ampersand. So basically it's a form of laziness. It's late here in Stuttgart right now, so I'm a bit tired. Now this is taking a lot of compile because I actually didn't use the user source directory. This is actually directly from the help files over at Yate. They recommend doing this in the user source directory. So when I compiled Yate before, it was in my downloads folder. Anyway, I'm just having you guys follow the documentation. RTFM, always RTFM. Okay, so after that's done, we're just going to run. Don't forget to run ldconfig. ldconfig basically updates your paths to your libraries. So if you don't run that, system might not be able to find stuff. There's probably a much sexier answer than that, but basically it's like, I forgot what it stands for, library something, library database, I don't know. Basically updates your libraries and paths and stuff. Okay. Oh, by the way, I am astronomically addicted to Trolley sour gummy worms. I don't know what the deal is. I don't really care for chocolate. I don't really care for sweets in general, but for some reason I'm completely addicted to Trolley sour gummy worms. So if anyone wants to send me a gift, Trolley sour gummy worms. All right, it's done. Okay. Remember what I told you? All right. Next, we're going to install YateBTS. Okay. For any of you newbies out there, if you hit Tab key while typing in a file name or you know, anything, it will give you, it'll try and autocomplete and show you a list of potential commands, potential folders, or potential file names. So it's a really great key for us lazy people. Okay, so as you guys can see in my downloads folder, I have I've downloaded YateBTS. You guys can grab that from the YateBTS website, which is yatebts.com. And that's as simple as running autogen.sh. And we are going to do the same thing, configure prefix equals to user local, make install, and we're going to run ldconfig and let it do its thing. Okay, so theoretically, we should have both Yate and YateBTS installed, unless you guys ran into some compile errors, in which case I can't help you. uh, if you guys run into any issues, go to Freenode, irc.freenode, and go to the Yate channel, join the Yate channel, and there's a lot of people there that are generally really cool and willing to help. There's also a forum. If you go to the Yate forum, you can post your question and any compile errors or any issues there, and hopefully be up and running. All right, so this is the most important part. This is where we're going to actually configure our ybts.conf file, and it is located in user local etc yate ybts.conf. And okay, you guys need to be really careful when you're editing this file. You want to grab your mobile country code and your band. So your band is the band, the GSM 900, for example, is where I'm at here in Europe. If you go to, and I'll link to some websites below, but mcc-mnc.com, I believe, you can pull, will actually give you a list of all of those. Let me just pull it up for you. So mcc-mnc, I want to say mcc-mnc.com. Yeah. So if you guys look here, you guys will see a list of all the countries, and it will actually give you the mobile country code and the mobile network code for that area. And I'll explain this more in the article, but basically your mobile country code and your mobile network code identify where particular mobile equipment is and forms part of what's called the IMSI. But anyway, here you'll see Germany, the mobile country code is 262. And depending on the mobile phone company, whether it's E+, Telecom, Vodafone, it's going to have a different MNC. Okay, so there's your MCC, there's your MNC. The other thing is you can actually run a code on your cell phone. This is actually a pretty neat little hack. Let me show you guys how to do this. I will post these codes in the description as well, but it's on iPhone, it's star 3001 pound 12345 pound star, and then hit the green button, and you will see, I don't know if you guys can see this, but you will enter a field test screen where you can get your SIM info, pretty neat info, and you can grab, your your downlink frequency and stuff like that. I think mine is 1300. Anyway, pretty neat little nerdy geeky stuff you can do with your phone. There's all kinds of ways to actually get this info that I'm talking about for this config file. But in any case, these are the values that you're going to need to fill in. You must fill in these sections of the GSM section. The other sections will default, but you have to be really careful. You need to fill this stuff out. And now you can create what's called a test network, which will be 001 and 01, which is my recommendation. But just make sure you get all this stuff filled out and filled out properly. And then the next thing that you're going to want to modify is the user local, let's see, Yate ysnmp agent.conf file. Now, running Yate as root is well, just a service in general as root is an incredibly bad idea. As penetration testers, we should eat our own dog food. You don't want to start Yate as super user. So if you're going to start as a normal user, which is what we did by adding our user ID to the Yate group, is you can't bind to a local port less than port 1024. So anything from port 1 to 1024 are what are called reserved port numbers. Those are ports that if you want to run a service on those ports, you have to be root. Which is why when hackers overflow a service that's bound to a specific port number under port 1024, it's running as root, you will drop in as root level access if you successfully buffer overflow, for example, that service. So my point being is that if you, with these port numbers for SNMP, it's 161, 162, you have to be root to bind to those ports. So you want to modify this file and change port 161 here to like 2061 or 1061. And then the port 162, you want to change that to like port 1062. Anything above port 1024 will work. Okay. All right. Next, you're going to want to update the subscribers.conf file. And that's in user local etc Yate subscribers.conf. And this is where you're going to put in your country code for your country. And this regexp dot star, you're going to want to put dot star here. What does dot star mean? Dot star means all mobile devices, meaning that any mobile device within range, it's going to cause that mobile device to associate to your base station. That's how we're going to get the TCU to associate to our rogue base station, okay? Because we're projecting a stronger signal. Okay, final steps in this is to install nib. And actually, because we've installed Apache and PHP, there's really nothing to install for nib. So you're just going to go to var www html, and you're just going to do an ln -s user local share Yate NIPC web to NIPC. And what that's going to do is it's going to create what's called a symbolic link from the user local share Yate NIPC directory. It's going to create a symbolic link into this main web root for Apache so we can access those files. And you need to make sure you do the chmod command, or we're not going to be able to see any of that stuff for permissions. Okay. And then you're just going to do an etc init.d Apache 2, and then you're going to do start. Okay. All right, so that's all you do. We should be up and running. And if we just do localhost /NIPC, we will see the GUI for the BTS NIPC or network inbox. So the thing that you're going to want to pay attention to is going to be in this BTS configuration screen. You're going to see your radio band, basically all the settings that we set before. The identity short name. Now, this is a misnomer. Let me Mixed with misnomer, would that be right? Anyway, this is not how your stuff is going to show up when we fire up our base station. It's not going to say evil BTS. What it's going to do is it's going to give you the MCC and the MNC because we're not really a legitimate tower. We don't have the ability to broadcast out this short name. It's basically going to be seen as a test network. The only way I'm just not even gonna get into that. But basically, don't freak out if you don't see evil BTS. It's gonna say your mobile country code MNC. Okay, this is where it gets fun. Okay, you guys ready? All right, here we go. We are going to start our evil BTS, or our evil Haxer thing. All right, and we're gonna do Yate minus S. Okay. Let me show you guys the BladeRF as we do this. Okay. Hopefully when you fire this thing up, you do not see any error messages, and the final line should say state changed running radio up. Now you guys can see those 3 LEDs right there. I don't know if you guys can see that. See that middle one? That's your received transit. That means it's up and running and it's processing it. Now, oh, you know what? One thing I did forget to mention. If you go back to the web UI, go to tapping and make sure you have GSM and GPRS turned on, and then hit submit and then restart Yate. This will allow us to actually capture the GSM and SMS text messages and stuff with Wireshark. Yeah, that's the fun stuff, right? All right, so we now have a fully running base station. So I'm gonna load up my iPhone here. And let me just kind of go back to the screen so you guys can see this as I join this network. All right, so I'm gonna go to carrier on my iPhone. Do you see that? And I'm just gonna I'm gonna turn off automatic, okay? And it's gonna search for local cell towers or local service companies, mobile carriers near my phone. I think it still says searching. I can see the reflection in my screen. So it should show up telecom E2, I think will show up as another MC in this, another carrier in this area. Okay. So you guys can see telecom.de, E plus, and Vodafone.de. And we should see our test network or MCC and MNC show up here in a minute. Come on. And there we go. Do you guys see that? So right there, you guys see that country code 256 and MNC01. If I click on that, I will be joining the network. Do you guys see what just happened on my screen? Okay. And look at my network up in the top right-hand corner. I don't know if you guys can see that, but it says 712, okay? So I'm now connected to the cell network, all right? So the neat thing about about running this is you will actually get a text message. Let me show you guys. From 12345, and it says your allocated phone number. Welcome. Thank you for installing YateBTS. Call David at David32843. All right. So it will actually assign you a phone number when you connect your cell phone to it. So you actually are running your own cell network. And here's your telephone number that you've been assigned. Now, the neat thing about YateBTS is it actually has a built-in chatbot. So if you send a text message to 35492, you can actually chat with the chatbot. Let's say hello to our chatbot. And look at that. Our hello message went through and it looks like we got a response. Okay, how are you today? What would you like to discuss? How is the weather? Have you asked anyone else? So, all right, pretty neat. So this, we have a fully functioning network. Now, let me actually show you guys how cool this is. I'm going to actually join another cell phone to the network and actually place a call over the network and send a text message. Hey, Vicky, can I get your cell phone? So we can take, so I have an iPhone here and I have an Android here. And I'm just going to join this Android phone to our new network. Okay, so let's go to settings, connections. Where do they put that stuff? Mobile networks, network operators, and then we're going to do search now. Okay, that's all you do. And it's going to send out an attempt to try and search for local base stations. And it should hopefully find ours. I'm actually supposed to be on a diet right now. Let's see how well that was going. You're going to get message output to that screen. Oh, let me show you guys this while we're waiting on this. I want to show you guys Wireshark. Hmm. All right. Blah, blah, blah. All right, so your local loopback interface is where all of the packets from the network will be coming. Okay, so if there's any mobile equipment that's joined our network, we will see, we will be able to record those packets here in Wireshark. So it looks like we have found our local base station. We're just going to click on it, 25601. It says registering on 25601. And we have successfully joined the network. Okay. So now we should get a message welcoming us to the network. And yes, we got a message. You guys can see that. Let me just show you guys that output screen. So let me pull up messages. Your allocated phone number is 256-290-6929. Thank you for installing YateBTS. Okay, so I'm just going to show you guys what this looks like. I'm, where is it at? I'm going to call the number that I was assigned. Okay, so I'm going to go here and I'm going to dial 256-16-79859. And I'm just going to call that number. Pretty neat, huh? So it says it's from Costa Rica, but let's go ahead and take the call. So you guys can hear from it's messed up audio. Anyway, so that that you can see is working. So really cool stuff. So what we've done is we've upgraded our BladeRF to the latest firmware. We've installed all the necessary BladeRF software. We have um, installed GNU Radio, GQRX. We have installed YateBTS, and we've configured it to run our own cell tower, our own base station. Now, what we would then do is take this base station and put it, as relatively as close as possible to the TCU, and um, try and get that TCU to automatically associate to our base station. We have, just putting it near the TCU isn't going to really do it. What we've had to do in the past is either turn the car off, turn the car back on, and then as soon as it comes back, it's just designed to work like any cell phone. It's going to associate to the strongest signal. Same thing with Wi-Fi, same thing with cell. It's going to associate with the strongest signal. It's the way it works. So the neat thing about that is that if you initially don't get a connection from the, oh, it looks like someone else may be connecting to us. I better turn this thing off. I'm sure there's a lot of cell phones in the hotel I'm in right now. Anyway, just be really careful when you're doing this. Understand that it's illegal, it's against the law to um, to connect your test network to legitimate base stations and attempt to set up an outflow to a legitimate base station, an output. And you can actually do that within, if you pull up, what am I doing? If you pull up the GUI, you can actually see where there's an outgoing section where you can actually define um, SIP configuration to actually send those outbound. So cell phone calls and text messages will go through. Again, if you are not a legitimate carrier, that is very illegal. Read that as jail time. So be really careful with what you're doing. The point really is to just get the TCU to connect to you so you can then begin capturing the packets and analyzing them. If you want to find the SMS messages, you just type in GSM tap and you will see all of the GSM tap messages within Wireshark. Okay. So that's it for this episode. I will see you in the next episode where we'll talk about taking this attack further and also playing with the pineapple and setting up host APD and setting up an evil twin and doing man-in-the-middle attacks. Thank you, everyone. If you haven't done so already, please subscribe. I am releasing videos as part of this series regularly, and I also have conferences on my YouTube channel that I've spoken at in Tokyo, in Europe, Germany, the UK. I'm speaking at several conferences in 2018, so definitely subscribe, and that way you can get notifications when I post new videos, when I speak at new conferences. I'll be speaking in China in 2018 as well as Sweden, so look forward to seeing everyone in the next video. Bye-bye.